sketching graphs of exponential and logarithmic functions. You guys have been sketching stuff since probably 5th, 6th, 7th grade. This is no different. You're going to pick some x values, and you're going to put the x values in the table. You're going to plug the x values into the variable, and that will give you the y values. And once you have the x and the y values, you can plot a point. All right, let's get going. So we have y is equal to 4 to the x, and I'm going to just pick some x values. I picked -2, -1, 0, 1, 2. So I'm just going to plug those into the variable. Well, 4 to the -2 to the -2nd, remember, that is the same as saying 1 over 4 squared, which is 1/16. And when it's 4 to the -1, that becomes 4 to the first. 4 to the first is 4. So there you have it. And then any non-zero to the 0 is 1. 4 to the first is 4. 4 to the second is 16. So we're going to take these coordinate values, all of them. We're going to plot the points and graph that. And as we read, notice, as we read left to right, the values get higher, 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 higher. As you read left to right, if the values are increasing, that's called exponential growth. And notice the base number is an integer. All right, so when the base number is an integer, that's exponential growth. All right, I'm going to erase this stuff, and then we're going to talk about what happens when you've got a fraction. So we're going to pick, we're going to pick x values. I just make it easy on myself. You can pick other values, but if you pick really big numbers, you're going to have to make your graph really, really big. So again, I'm a lazy mathematician. So I'm going to pick really easy numbers for myself. And we're going to plug those values in for x. And remember, if it's 1/3 to the negative exponent, you're going to rewrite that as 3 over 1. To the positive exponent. And so you end up with 9. And when the negative exponent is 1, then you end up with 3. And so forth. So there you have it. You have all your coordinate points. You plot those coordinate points, and then look what we have. As we read left to right, those values are decreasing. And when you've got a function that as you read left to right, the values are decreasing, that's called exponential decay. And then notice, for exponential decay, the base number is a fraction. So when it's exponential growth, the base number is an integer. When it's exponential decay, when the values are decreasing, the base number is a fraction. All right, so logarithmic graphs, and we've been practicing these a little bit. Remember, the parent graph looks like this, right? Of the log base 10, or any base kind of looks like this. And when it's a natural log, they look very similar. It's a little bit different. The natural log of base e, it increases a little bit more rapidly than log base 10, but their graphs are very similar. And when you plug values in, then you have points. But this is what I want to point out for this one, because it's the same process. But remember when we were doing parent graphs, that if you know the basic parent graph, so notice this says x subtract 1. Well, whatever's on the inside with the parentheses, that's what tells you that this parent graph is going to shift left or right, and it's whatever's the opposite. So instead of the opposite of -1 is +1. So this point right here would now be shifted to here. And this tells us how it shifts up and down. So now we can pick this point, get shifted down, and I can have this now go away. So this entire graph right here now is going to look more like this. That invisible asymptote that was here is now, it got moved over one, and the invisible asymptote that was there, it got moved down one. And so notice, it got shifted down one, sorry. So that asymptote is right underneath that graph right there. Let me go ahead and, erase that. So the asymptote that got moved down one, so the new graph, it got moved to the right, then got moved down, so it's hitting that point, and then now look at, it's going right above that new asymptote. And the same with this one over here, it's the natural log. This says x plus 6. And on the outside it says plus 5. So what's the opposite of 6? Negative 6. So this asymptote that was on the y-axis is now going to be here at negative 6. And the point that was there is going to go back 6. So 1, 2, 3, 4, 5, 6. And this tells us to go up 5. So this point right here is going to be moved up 5. And now this whole graph can be redrawn. And did we have to do all the table of values? We didn't. So there's two different methods. You can do all the table of values, plug it into the calculator to figure out where the points are graphed, or you can look at the function and then just use the transformation methods that we have used before. All right, so that's going to be it for this one.